Hello 108 students, Mr. McHugh here with you. Welcome to Chapter 8 where we are going to work on roots, radicals, and root functions here. So we're going to kick off section 8.1 working with radical expressions and graphs. We're going to try and explain a couple things here to get going. Most of this is basic material, so I'll try to go through this fairly smooth fashion, but make sure you understand some of the symbols that are going on here. Okay, and I just want to commend everybody. We have completed up through chapter 7, and if you had 025 here at CWI, we have covered all that material in the first part of 108. Now we are moving into the new frontier of brand new material from here on out. So think of the train now is going to go up a steeper incline here as we push in the second half of the semester, and we're going to have to work just a little harder. But to get started here, radicals and expressions here, I just want to come over here to the side here before we start talking. I just want to do a basic idea here. If I took the number 6 and I put parentheses around it and I squared it and asked you what that result is, you know, exponents means take 6 times 6 and you would write 36. And so if you were going to go in the inverse direction, mathematicians came up with the symbol. They said take the square root of 36. And what they want to know is what times what times itself equals 36. And the answer is, of course, the question mark that I'm trying to find here is 6. Now it could be a plus 6. 6 times 6 is 36, and also a negative, and I'll go this way. Sometimes, I think I mentioned before, you see the symbol plus or minus 6. Okay, we usually think of it in the positive answers on these. So, but this is my lead in to help us. What did this symbol? This is a radical symbol. So let me jump up over here. You've got this radical symbol, or the radical sign was invented by mathematicians, and it means having radicand underneath it and take the nth root of it. Now we usually think of square roots, and so when you come over here and you don't see a number, it's assumed to be a 2. We hardly ever write it because it's just assumed to be that. Okay, so don't forget there's the nth root, the index number, and the result of that is the b. And what that means is if you took the b multiplied by itself, whatever the index number is, it would give you the radicand. Okay, so you can see they are inverse of each other, the operations. Okay, now on the order of square roots, if I could squeeze this in, I could possibly challenge us and say, what do you think? Take 2 as a base and take it to the exponent of 3, which means take 2 times 2 times 2. Take the base multiplied by itself 3 times. 2 times 2 is 4. 4 times 2 is 8. Now to go in reverse direction, you would put the 8 now goes is the radicand. It goes underneath the radical sign, and the index now is not a 2 but a 3, and therefore you're now taking what we call the cubed root. This was the square root. Okay, and we answer that question, what times itself gives you a positive 8, and you've got to realize that there's the answer sitting right there again, just like before, and the answer would be 2. So the cube root of 8 is 2. Okay, and we're now ready to move on. Okay, so let's pick up the pace here a little bit. You can see some of my examples here. What's the cube root of 64? 4 times 4 is 16 times 4 is 64. The fourth root of 16. Okay, the answer is 2 because watch what you do. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay, here's a fraction. 8/27. We're going later on. We're going to learn that you can take the cube root on the numerator and the denominator, or you can look at this as a fraction, but take the cube root of 8 is 2. The cube root of 27 is 3, and you're on your way. The fifth root of 32. Now here's a little hint here. You see this 32 is a pretty small number. You're taking the fifth root of it. It says you've got to find a base multiplied by itself 5 times. It's got to be a small number. Okay, so that's kind of our warm up on objective 1 here. Objective 2, finding principal roots here. Okay, the book, they get you going if the index number is even, the principal root is the square root of it. I try to remember if they stick the negative on the outside, here's what they want you to think of. Square root of 36, the principal root is 6. Also, the negative root is negative 6 like I talked about. If they want the negative root, they put the 36 underneath the radical sign. They put the negative out. I just drop that I drop the negative, excuse me, and that's how you get that. Okay. They go, oh, if A is negative and N is an even exponent, such as, oh, how about I got it right down here. What happens if you took the square root? Okay, A is -1 and you're taking the square root, so it's an even. And can you take the what number times itself equals -1? You could see me, I'm trying to work all this out. I was doing the fourth root, but let me just go and do the square root to make it easier. And guess what? Turns out you cannot come up with anything. Okay, big unknown right there. There's no number. A +1 times a +1 is +1, and -1 times a -1 is still a +1. You have to have a +1 times a -1 to achieve that -1, and that breaks the rules of what you're doing with the radical. Okay, so we're going to deal with this later on. However, look at this example I have down here. If I ask you to take the cube root of -8, if you took -2, multiplied it by itself 3 times, what would the result be? -2, negative times a 2, -2 times -2 is a +4. +4 times -2 is a -8. So if you have an odd numbered exponent and you had a negative number, you can come up with them. Okay, like over here, this fourth root here, -1. It's still you always come up with a positive here. All positives, 4 negatives multiplied together. Here's a positive. Here's a positive. Positive times a positive. Positive. So the big idea, remember, is if you're taking if your index is even and the radicand is odd, you can't do it. Okay, Mr. McHugh, I'm going to sign off here. We're getting warmed up here, so section 8.1, page 1's in the book, so I will see you for page 2, and we're going to keep working with radicals and some graphs coming up on the second page. Okay, I'll see you later. Bye.